Good afternoon, good morning, everyone, and welcome to the Voyantic webinar, which is conducted in cooperation with Avery Dennison, SmartRock, and Impinj. I think we could get slowly started. My name is Jennika Arvonen. I am Senior Marketing Manager at Voyantic, and I will be your host and moderator today. So our topic today is the evolution of RAIN RFID tagging in the automotive industry. This webinar will be recorded, and the recording will be shared with everyone who has registered to the event, so there's possibility to watch it afterwards on demand as well. We will soon start our content with the short presentation section, which will set our minds to the topic and remind us about the different factors that are impacting the development and the business environment. This introductory section will cover the history and evolution of tag products, the standards and scalability, and the tagging requirements. After the presentation, our panelists will have about 30 minutes time for the panel discussion. And if you feel like you would want to ask any question from our panelists, please feel free to post it on the Q&A window anytime. You should find the Q&A window at the bottom of the ribbon, the tool ribbon, or in the menu if you are joining on the mobile device. We will take the questions from the audience during the panel discussion and at the end of the webinar. While we're still waiting for rest of the participants to join, let me introduce you to our experts and the main characters of today. So first, we have my colleague Jesse Tuominen from Voyantic. Jesse is PhD and CTO of RFID technology at Voyantic. Jesse has been involved and contributing to the technology since its early days in 2005. He's working with the measurement methods, RF design, proof of concept, standards, protocols, industry collaboration, and IPR. Jesse is also the co-leader of the Manufacturing Quality Work Group at RAIN Alliance. And next we have Juho Partanen, co-founder of Voyantic. And in his current role, he is a Vice President, Market Transformation at Impinj, as well as the board member at RAIN Alliance. Juho has contributed to the key industry standards, for example, through the ISO and GS1, and he is an active advocate of RAIN technology, and I would say a trailblazer to driving the whole industry forward. And our true expert in the field, Lauri Hyytinen, who leads the global automotive market development at Avery Dennison SmartRock, which is known for being the world's leading provider of passive RFID transporters for automotive industry. With over 15 years of experience working with the top automotive companies, Lauri has been in the forefront of integrating RAIN RFID technology in the automotive processes. With that, I would like to hand over to Lauri.
Thanks, Jennika, and welcome to the webinar, everyone, also from my side. So, as Jennika told, my name is Lauri Hyytinen. I have worked over 15 years in the industry, and during that time, together with our partners, we have developed over 100 applications and projects successfully for the automotive industry. So today, I will give you a small or short recap of the technology development from the transponder side, kind of what has happened during the years. So if we start from the 2010, because I see that that's the time when product quality, performance, and price level reached the level that the high volume applications in the automotive area were possible and started to grow. So roughly at that time, we saw NXP launched the G2IM, we got the X3 from Alien, and Impinj has Monza 4 IC. So that was the starting point for the automotive application growth. So quality, performance, and price level was meeting the end users' requirements. Requirement normally on the field for all industrial applications is 2 to 4 meters read distance reliably. At that time, we reached that target with a big products like dog bone and short dipole, to mention a few. large footprint products offered reliable performance. So that was the starting point. When the technology developed, like 2015, we started to have a more sensitive ICs, which enabled longer reading distance. And we saw that kind of a belt-sized product, which was a bit smaller, easier to use, a bit cheaper, was coming to market standard for the automotive. And at the same time, certificates and kind of programs and standards enabled bigger, faster, kind of an easier implementation for the industry. But after that, also kind of the technology has continued to develop. So step by step, the IC sensitivity has improved. And roughly at the time, 2020, MiniWeb started to be our benchmark product for the automotive. What's remarkable with the MiniWeb is that it's roughly the size of the standard barcode label, and it's only kind of 1/4 of the footprint of the dog bone. So that was the time that kind of it's enabled for system integrators, very kind of easy implementations, fast-growing business, and wide applications in the kind of scalable applications in the automotive industry. And we see that this development is continuing. We see that there's a new great ICs coming like Impinj M800. It's enabled smaller products once again, but also new type of products, applications, and way to use the technology. When we look for the future, there's two clear trends which we are seeing. One is this plug and play, easy to use applications. So with these new technologies, latest developments, we can build the products which are easier to use, offer immediate benefits for the end users to implementing the technology. So no special R&D developments needed, but utilizing the technology easier and faster. Another big kind of a trend and development now is the lifetime identification. So RAIN RFID offers unique ID for the items. And when it's embedded inside the product can be tire, car seat, or plastic box, for example. It survives the product's lifetime and offers the unique ID for the item. That, of course, supports the upcoming new standards and regulations like Digital Product Passport and PPWR in Europe. And it's also enable and offer completely new business models and applications. So that's kind of what we see that will be the big change for the industry. From transponder side, we start to see that we are ready for that. We can support that, but that's of course create new requirements. Today, most of the applications are still closed loop applications, meaning that one company is placing the products and utilizing the technology. In the future, when we have this lifetime identification, it creates a possibility for open loop applications where several companies are utilizing the same transponders. But that also creates a need that how to share information, what kind of standards that requires. And Juho Partanen will next tell you a bit more about the standards and scalability.
We'll be delighted to. It's always exciting to get online and happy to do that with esteemed experts like Lauri and Jesse. So a outlook into the standards and scalability, the remark here is that in order to see into the future, it's good to understand what's happened in the past. So starting with the standards, around 2010, the RFID industry was really at its infancy, and much of the work and deployments were based on standards that originated to the AIDC industry, VDA 5510 being a good example, already specifying tagging and the memory content utilized in the automotive industry. Now, over time, it became evident that more RFID-specific standards were required, and a very good example came from the tire industry that initiated a ISO process to create a tire RFID standard. It's a lengthy process to create a new standard, and the ISO 29909 standard family, a family of 4 standards, came out in 2019. The process of creating that standard deserves recognition, because the tire manufacturers really came together on a global scale to work on that standard, and very good decisions were made. I think it's a landmark standard, really paving the way for other standards that may be needed in the future. Now, entering 2020, I think the fundamental plot behind much of what's happened in the industry is to build scale. For the automotive sector, coming up with a ODET publication early 2020s is one good example. And the GS1 EPC tag data standard, DDS 2.0, coming out just last year, is also a very important step forward for the industry on the identifier and data sharing side. As Lauri mentioned, the next phase is very much around life cycle traceability being driven in many fronts. And actually, if you could take the next slide, please. In the narrative of building scale, first to recognize for the RFID industry the emergence of the RAIN Alliance some 11 years ago. That association really brought together the stakeholders on a global scale that were driving this industry forward. Another interesting landmark in 2018, the harmonized frequency band, also in Europe, opening up the frequency bands gradually around 915 to 921 megahertz. It is a future-proofing aspects, a very valuable asset for our industry to have a global harmonized frequency band. I'll highlight GDSO because Global Data Service Organization was born soon after the ISO 29909 for tire industry was published, and GDSO specifically aims to facilitate the data transfer and access for the tire industry and even beyond. Finally, arriving back to the theme of lifecycle traceability, DPP obviously being one of the fundamental drivers, and behind DPP you have the Eco-Design for Sustainable Products, the ESPR legislation. Gradually, those will also shape the landscape around automotive parts and consumers in the automotive industry. So the requirements that it brings for tagging, I think actually will be next covered by Jesse, who will give you a more technical outlook into the last 20 years of RAIN RFID adoption in the automotive industry. So please, Jesse, take it away.
Thank you, Juho. I don't know about technical, but at least different. So in my line of work during the last 20 years, working with developing tag test methods and test equipment, it's been really a front row seat to see tags and ICs develop. So I would like to start from 5 years further back as my colleagues, from year 2005. And for me personally, 2005 has always been the year one, the start of counting the RAIN time. That's when the protocol was released, the first chips, the first tags, and readers were also launched to the market. Back then, perhaps the only common way to communicate tag performance was the ISO 18046-3 test methods for tag performance. That was something, but not really great. Performance was measured for a single tag without attaching it to any material or item. Also, the standard never really caught any proper traction on the market. The result of this was that tags were often tuned very peaky. So attach the tag to any real material, and you are left with a fraction of the read range you had. And it was generally considered that the UHF tags just don't work on metals, liquids, or even any dense dielectrics. That was back then, but around 5 years later, the ARC RFID lab started its operation. The purpose of ARC was to take complexity and workload away from major retail chains, such as Walmart, so that the RFID would just work from them. The ARC specs, as they call them, brought new test requirements to the market that focused not only on tags read range, but the sensitivity on relevant materials, the backscatter levels on those, and the tag's tolerance to the more tags in the form of stacked items and tag close coupling effects. Tag manufacturers had to learn how to design tags that are more general purpose with a wider spanning tuning window, and in that manner, more tolerant to a range of materials. Soon after this, Voyantic also offered with the tag performance system automated ARC spec measurement capability and a Voyantic reference material set, which is undoubtedly the most used material reference set in the RAIN market today. Sector-specific RFID standards and tagging standards started to then slowly appear as the RFID gained adoption. And one of the early active sectors was the aerospace industry. But very soon after that, several others followed, such as automotive, and also medical, tire, food, luggage, road tolling, railroad, and so on and so on. What was very cumbersome was that most of these sectors tried to reinvent how to specify tag performance. And I must say that as a company, we, Voyantic, must have spent at least 1,000 hours in these standardization meetings trying to steer the work to a common direction so that same methods, same terminology and equipment could always be used in any sector. One thing I would like to highlight from this era is that several quality-oriented sectors made it very clear that even rare misreads or memory errors were just not tolerated anymore, and the tag chips had to evolve to provide better means to detect and avoid such. And in 2015, Impinj launched the Monza R6 chip series that had new features like the Integra and margin read to safeguard the memory contents. In around then 2016, the tagged item performance protocol was created, TIP. As the name suggests, it doesn't care about the label, the reference material, or any of such. Only that the tagged item is readable according to the grade. It's really handy for source and embedded tagging. And as an open standard, anybody can create these grades and test against their own grades. However, by this time, latest through the TIPP and ARC, And in general, through the incremental chip sensitivity improvement and the auto-tuning tag front ends, it was getting more and more evident that the tag sensitivity was not always the weakest link, but instead the tag's backscatter strength. Tag designers were not that knowledgeable on how to optimize the backscatter, and in getting the simulation tools to predict backscatter strength correctly can be extremely tricky. And it seems that the backscatter optimization is something that sets good tag designers apart from the average ones. One helping hand to this comes from the Gen 2X protocol feature extension that has taken enormous steps forward on improving the tag to reader link speed and sensitivity. Finally, the big change at hand currently is the shift to tag product permanently, not just till the point of sale. This puts huge demand on the quality of the tagging, especially in the form of survivability. Imagine that car tires are driven in the mud, snow and gravel, clothes are washed and tumbled, and so on. The RFID part should not fail before the item. And we will see a lot more tag form factors besides the typical labels in the near future. Finally, everything in the RAIN industry, everything will get a whole lot more interesting when both the consumer mobile phones start to get RAIN as a standard feature and when everything is tagged for life. Just imagine all the possibilities and everything that will change.
Thank you, gentlemen, for the great presentation and introduction to our topic. And now it's time to move on to the panel discussion on top of what we just heard. The discussion will roughly follow these three themes. So first, we will talk a little bit about the current state of the market and adoption. Secondly, the impact of the technical developments. And then we will leave some time also to speculate on the future trends. But as mentioned, feel free to post your questions anytime and we will take them up. But let's dive into the topic and start our discussion. And Lauri, I will throw first a difficult question for you. So the RAIN RFID is evolving and adoption is broader with the technology gaining foothold in the automotive industry way beyond tires. How do you view the current level of adoption? Is there a way to estimate the current level of adoption, for example, in terms of suppliers, OEMs using RAIN, or the share of car assembly parts tagged with RAIN?
That's a good, Jennika, as you said, tricky question, because the challenge is that we very often we are not allowed to publish the projects. But what I can tell you is that as mentioned, over 100 projects made together with us and our partners, and there are lots of talented system integrators and converters on the field who can support the industry today. And that's important. So how I see the market situation today, it's good, it's growing. Today it's European driven still, but we see more and more applications also outside of Europe. And if I think about the trend at the moment, is that the projects are getting larger, wider, more global. And what I was really enjoying following Juho's and Jesse's presentations that how the market will change and develop when it's more open loop applications, lifetime identification, and what kind of possibilities and options that will bring for the whole industry.
I might maybe drill Lauri a bit more here. So automotive industry, how many cars are produced every year?
I think it's roughly 90 million cars what's manufactured.
So if you then consider the amount of components or sub-modules or electronic control units that go into a typical car? You know, what kind of figures are we talking of?
That's good, and there's lots of variation about the number of components per car. It depends, of course, the car type and what level of components we are discussing, but I would say that on average it could be around 2,000 components per car.
Yeah, that's a significant amount. And probably if you scan a new car for RAIN tags today, the count will easily hit tens. Do we even go over 100?
I don't believe, at least I haven't seen a car with over 100, but we are getting close to that. So, and that's very remarkable and very interesting to see that. And interesting that it's almost every vehicle you can find RAIN RFID there.
Funny enough, that was exactly the exercise I did before the webinar. I wanted to scan my car, being 3 years old, and in the garage, I scanned many other cars. And it's clear that the newer car you scan, the more and more you find, especially with European brands. I think it was clear I found tags in tires and bumpers. What are the most common places to find tags in?
I would say that the most common is car seats and bumpers. That's where we started. And there, I would say that it's very easy to find the benefits because those are relatively big items delivered from tier ones for the OEMs very often. All these logistics, warehouse management, and also the production control is very often organized with RFID. But also there, you still find the RFID there inside the product. It's possible to use that. And that's what I think we should, as an industry, think a bit more that how to utilize the technology, what kind of applications, solutions, recycling, reuse, kind of possibilities that could open to us.
About our panelists.
To answer,
yeah.
Just you, I think I found a maximum of 30 or 40 tags in the newest cars.
It's a nice figure and going up for sure.
Yeah, I was about to ask about the standards. We heard a short introduction into those as well, and I would like to ask your opinions about that. So, for example, current VDA standards don't align with the mainstream RAIN adoption, namely the 96-bit tags. Requiring a large memory on tag limits the selection of available tagging products and drives up the unit cost of tagging. Do you think this slows down the adoption in the automotive industry?
Would Lauri want to start?
I can start. As you saw from Juho's presentation, VDA started that. It was very, very important first step, first push for the industry to accept the technologies, to start utilizing that. Of course, the industry has developed. We see that the different needs, different applications than what we saw kind of 15 years ago. So it's changing, but still we have those applications running and standards are there, and maybe it's a bit old-fashioned in a way, but of course those were the starting points for this industry.
Building on that, I think VDA and the German automotive industry in general was a forerunner, and around that standard came out. Obviously, there's been already work done before the publication. So I have to give kudos to the technical work done at that time without exact knowledge of where the future of our technology will be in. I think they did a good job over there back then, almost 15-20 years ago. The label or the memory requirement for the transponders, the mainstream today in retail is 96 bits of memory in the UII memory bank or the EPC, and that does not match with the standards written 15 years ago. So that's a fundamental discrepancy. But having said that, you know, the conservative automotive industry chose to lean on ISO standards very heavily back then. I think they still do. It's a conservative, let's say, tactic to follow, and I think also it has given good results for our industry. And now the question is just that how to enable the scalability from the current levels of adoption, say hundreds of millions of tags every year, to the amount of billions of tags. There might be a gap between the standards and what is practically required. Yes, any further remarks from your side?
No, the only thing I'm thinking, numbering is more important, but the 128 bits of EPC, that's practically supported by almost any IC. So that doesn't really narrow down the IC selection.
Yeah, and I see that also as the technology has developed, also a little bit the use cases have changed. So when we started like 20 years ago or 15 years ago, it was very often focused to production control applications. So directly for the car production lines. And now we have heard lots about this lifetime identification and open loop applications. And maybe, Juho, I don't know, maybe that could be the way how to update the standards and update kind of the used technology, that when we move for these new type of use cases and applications, to update the standards for that and make sure that the standard supports the future needs.
Absolutely. So if I briefly comment the new breed of use cases, there's a few technical aspects. Consider first, as referred to Jesse earlier, the interface is one limiting factor, and recent developments not directly in standard, well, actually in standards. So the Gen 2 version 3 has certain aspects to it that improve the over-the-air interface, and the Impinj Gen 2X does the same. Always technology moves forward faster than the standards do. But then there's the other side, not directly linked with the interface on the numbering side and data sharing. You know, data is moving to the cloud. That is definitely a trend we see across all the industries. So who owns the data? Who has access to the data? How to authenticate different users? You know, those are some of the let's say more frequent questions over the past 5 years as deployments scale out of you know, closed loop systems into open loop systems covering the whole supply chains. Take tires, for example. Adoption started with tire manufacturers, and now it's spreading to tire distribution and even the usage of tires. So the variety in use cases is definitely bigger today, and as we can also see from the questions coming in, the requirements of reading tires, for example, out there in the field are very different from the requirements at the factory level.
Yeah, that's true. And in the past, RAIN RFID was quite often used as a data carrier. So that was data was saved inside the transponder. Now it's just unique ID what we get, and the data is really in the cloud. So that the backend system has the information, and that's how I see also in the future it will be more and more.
There was also a question from audience that are there any standardization efforts around sensor integration with RAIN RFIDs? Do you want to summarize the answer to that, or do you think that it was already covered?
Well, yes, you know the TDS 2.0 a bit better than I do, but I do understand it created the structures for anyone to use user memory to store various types of information, including the type of information generated by sensors. But as a personal comment, while I was a true believer in RAIN RFID sensing some 10 years ago, I think the heart and core of the value creation around RAIN today is still the identifier, and sensoring might be something around the corner. There are standard structures that already support sensoring, but to break in a big way on the market as a sensoring technology, I think we are still quite far from that today.
I agree, and if you need sensors to be used with the RAIN technology, there are a lot of good sensors. And as far as standards go, the ISO 18063 has always been the front runner on specifying how sensors are related to standards, and the GS1 air interface standard typically comes a little bit behind, a year or two. And now there's a mention of the spotlight, not spotlight, but the help me, what's the term? Anyhow, on censoring on the version 3 standard of the air interface.
Maybe to build on that, one thought that came to mind also, sensoring is sort of being re-specified. You know, if we traditionally think sensing as acquiring temperature or pressure or something, going forward, I think sensing can be also keeping a track of what tires are underneath the car, what other items are in the car. If you take your car to a maintenance service, for example, you know, the car could well sense whether any of the parts or tires have been changed during the maintenance procedures. So sensing is not only about the ambient parameters, it's also about what is in the car, what are the parts in the car, when do changes occur, and were those changes in fact anticipated, or is it a surprise someone changed the set of your car tires to a older ones, for example, when you loaned out your car to someone?
Exactly, and that's one thing people oversee or forget often, that the basic track and trace is kind of sensing.
Yeah, and how to optimize things. So when there's more kind of automated machines and kind of the things, you need to understand what are the components there, like kind of the tires and things like that for the car, and how to optimize other things there. So what's the components and the equipments.
Maybe another track, looking at the questions coming through the Q&A. Lauri, could you talk a bit about what kind of labels were traditionally used in the automotive industry, and what are the current types of labels? What has been the change, you know, thickness, durability, because that has a big impact on what the label converters that supply to the automotive industry actually are faced with in their day-to-day operations.
Good question. again, a tricky one because as Jesse mentioned, 30 different RFID tags in a car means that you have most likely at least 20 different car components marked with RFID, which might require different things. Of course, the tags are smaller, so now those are similar sized than standard kind of barcode labels. So those are much easier to find the suitable location for that. So the changes are, of course, the size. Of course, the converters are experts checking the suitable face materials, that it survives the required conditions, temperature, some chemicals, what's there, because also the quality, what you raised earlier and Jesse kind of highlighted, quality is the key thing in the automotive, and label quality it's not kind of only Avery Dennison us kind of offering the inlays, it's not only Impinj offering the ICs, but it's every single kind of a company in the supply chain who needs to be responsible of that and handling that and take care of that. Label converters, system integrators, that together we build the quality for the end users. So it could be labels for the cable harnesses, how to attach that, how to build that it's readable at every single phase when cables are not attached for the vehicle yet. Those are in the box, for example, or in the kind of in the assembly line, or assemble 10 for the vehicle. So how to guarantee that, and in these changing conditions, how to guarantee the kind of reliable reading. So that's something what kind of I would say the change is that we started from the easy objects, bumpers and seats. Now we have developed and move forward for more demanding items. Cable harness mentioned, airbags, different interior panels, you name it. So almost all components in a car has been marked in the separate projects, and every time we need to work with our kind of partners and with the experts to understand what are the requirements for this component and this application. Did I answer you the question?
I think partially you did, and building on that, I do assume that more and more on metal functionality is required from the labels, correct?
Correct. On metal parts, so of course, there's lots of metal components in a car. How to do that, traditional kind of a spacer, foam spacer or something like that, that's typical, but there's lots of different ways also to how to mark metal objects. But yeah, of course, metal has been one of the challenges in the past for RAIN RFID. This challenge and also the benefits with the reflections, but that's of course something what needs to be taken care of. Think about how it's for the curved surface, thickness of the product, so it's suitable for the printers and for every step in the kind of project.
So actually you mentioned printers and almost in the same sentence you mentioned on metal labels. So from the label converter perspective, do you see a good supply of available printers or other machinery equipment that they can use to process on metal labels that are typically thicker than the traditional labels?
There are options. Of course, there's also limitations, and that's something what needs to go hand in hand. That what is the suitable label and what is the used hardware. So I think that's still the area where we will see developments in the future. So how to make those easier to use. There's more products there, and in a way we cannot kind of require that the person who's using the technology needs to have a high-level technical understanding or knowledge about the requirements. So that was one part of this plug-and-play, easy-to-use things. That's the direction where we need to drive that when the volumes are ramping up. So how to guarantee that person who doesn't have a kind of a deep RFID knowledge can easily and reliably still utilize the technology.
Maybe to mention the obvious that not all the parts in automotive industry are marked with labels anymore. So embedded tagging is more and more an option, like the tire industry obviously is showing the string type of a tag that's embedded, baked basically inside the tire structure, has nothing to do with labels. Is that a fair statement?
That's a fair statement, yes, and it's built to be part of the tire during the production, and it's protected inside the product. So that's offering this lifetime identification, and that's of course then kind of an identifier for the tire is placed inside, and like now there's a reliable technology for that. And now I think the next step is to build the applications and solutions there that how to utilize that. What are the benefits when we have tires with RFID, how to build the applications, business cases, and use cases around that. And I think the same goes with many other objects. So Jesse mentioned the tags inside the car. Who will use those now? Those are still functional inside Jesse's car. Is there reuse, recycle, or kind of who will benefit of the technology which is still in place there?
And talking about embedded tags and molding tags into the parts and products, for many parts, that's the only way. If the tag is supposed to give benefit for years to come. And if you think of a car as an environment, engine bays get very hot, it's very freezing outside. Cars also see a lot of liquids, oil, washing, detergent. So it's a very rough place for a label to stick to for years, or be readable, like Juho mentioned, if there's the secondary code, the barcode, QR code, something else. It's very hard for those to survive.
That's true, but that's why there's also specialized converters who have years of experience working in this industry, how to select the suitable materials and how to qualify labels for that. And it's great to see that more and more those traditional automotive label converters during the last years have started to implement RFID for their offering and processes. So I see that embedded, it will grow for sure, and there's clear needs for that, and many kind of products will require that. But then there are also growing demand for labels, and also kind of protected high-end labels, and especially the, of course, metal objects. So it's tricky to build in kind of there, of course, some solutions, but still labels very often for those will be the easiest and most cost efficient way to mark those.
It's an interesting point, and that you kind of raised. Did I understand right that high-end labels for automotive, for instance, that they might have better adhesives, better film quality?
Absolutely. We have, like I can tell from our side, we have specialized and optimized product range for automotive. So we have own tags for automotive, and then of course we have certain converters who have more specialized for that. So they have qualified and certified materials for that, special adhesives and face laminates and printing technologies, and also protection foils for that. So yes, and that's kind of what this industry expects and requires, and this reliability, just underlying that, that's the number one thing in the industry here. That I say that that's all of us kind of responsibility, that when we drive that forward, we keep that in mind and work together to even improve that.
And just jump 10 minutes back, the word I was searching earlier was the snapshot sensors. And thanks Bertus for also pointing that out in the questions and answers.
Maybe building on the discussion so far, so we see the adoption of RAIN RFID technology in automotive industry picking up. We've discussed the impact on tagging methods, the requirements around quality, data governance, and so forth. Maybe looking into the future and building on some of the questions I see in the Q&A, I have to say that the innovation on the reader side, the consumer side of having tagged items, tagged car parts available and readable is quite exciting to me, frankly. As we think of how cars have evolved over the past 20 years, they are practically amusement parks today, amusement parks that can be easily moved from place A to place B. So to have those infotainment systems RAIN enabled, giving new, as we talked earlier, sensing capabilities, information about what's happening in the car, how car is being maintained, how authentic the car is at one point in time. That will over time even impact the value of those vehicles. So innovation on the reader side, how to manage the information, how consumers can benefit of these new prevalent tagging all around in that space. It's quite exciting to see where we are headed into.
And Juho, I think kind of Impinj and several companies have done lots of great development for that. I think in the retail area where we have hundreds and kind of thousands of products close to each other, do you see that? Is there some latest developments? What do you see that in the industry and automotive we should keep in mind and consider when also in our industry the number of tags will grow? Is there some key learnings or something that what we should take in kind of into consideration future when we are moving step by step to that direction?
When the abilities to trace items over their life cycle increases, what's happened in retail, the retailers are able to cut shrinkage. They are better able to authenticate products. As we jump into the consumer space, consumers will be better able to authenticate products. So I think there's a tremendous value add available for us. It should work in automotive industry as it's worked in other industries. So that's one form of value creation that I'm really looking forward to. Convenience then being additional, can you build loyalty around certain brands just by making the amusement park you call a car today even more convenient going forward? Think of family holidays, whatever. Yeah, I think the potential is never ending. We just need new people figuring out what are the killer apps going forward. Jennika, maybe coming up back to our script, is there an area we haven't yet covered in the discussion?
I think one of the keywords that we haven't yet covered, or the hot potatoes, are the digital product passports. So anything you would like to share about or thoughts on that?
If I maybe quickly start from the background, so I think that now the first item for the DPP will be EV batteries, so car batteries, and that will be the first thing which will be mandatory, and I think that will be mainly for the QR codes at the moment. The next thing will be then kind of the clothes and the tires. And of course, as we are working very closely with the tire industry, supporting that, and like Juho mentioned, these embedded tire tags. So working with kind of RAIN is very active, supporting that and helping the industry to evaluate the technology and train how to use the RAIN technology inside the tags for different. So one part is to get the transponder inside the tire. The other part is how to use the technology after that. And kind of it has been great to see kind of how RAIN as an association has been supporting that. And for example, the tire master classes, they have organized. It has been a great kind of a development from their side. But Juho and Jesse, how do you see the DPP developments on your sides?
If I'm brief before Juho, I just want to say that it's one of the first potential things that will bring RAIN and consumer together. Of course, we are still waiting for the RAIN to come to the mobile phones and the consumer devices, but that's the key thing that will be different.
Yeah, I think before maybe Juho heading over to you, I think that it's good to keep in mind that like Jesse said, there's two things what the DPP requires. One is this lifetime identification we mentioned earlier, and the second part is that consumer needs to have a capability to evaluate the product A and product B on the place of purchase. That what is the carbon footprint there, and compare between these two products and make the kind of a better choice at that stage. So that's the two critical steps and two key kind of cornerstones which I see that for what DPP requires. But Juho, what do you think?
If I think of the impact of DPP to our industry, which is the RAIN RFID industry, the impact should be very positive. Obviously, the demand for durable data carriers will increase, and by durable, the impact on the practicalities of tagging, I think, drives the industry towards embedded tagging specifically, because then the tag is better safe from harm if it's embedded in the structure of the item or the product, and cannot be removed, cannot be tampered with, which builds all the requirements for authenticating then the item or its life cycle as it changes ownership and so forth. You know, to have all that based is basically based on the ability to identify an item. If you do it based on QR codes, fine. If you do it based on NFC, fine. If you do it based on RAIN, I think there's simply more value that you can extract out of the identifier over the life cycle of the item. It's as simple as that, and it requires us to our industry to develop more embedded tagging methods that are fully compatible with the enormous volume of produced items across many different sectors, not only automotive and retail, but there's the food items, there's pharmaceuticals, there's many other industries that provide products directly for consumers that are soon required to carry a DPP. So it's a very positive outlook I see for the market that we are in.
Yeah, you're right. Kind of this is just the starting point what we see, and now you're kind of coming to the correct topic that it's kind of in the future it should be all items should have the identifiers.
Thank you.
Maybe just to add, DPP, while it's a very European thing right now, it's going to be also in other continents. Maybe the time span will be a couple of years longer, but I think in terms of sustainability, we need to have all the continents on board. So that builds the market opportunity even bigger.
And to
Thank you.
remember, while it's a European thing, it impacts almost entire world and all the companies importing to Europe.
I hate to cut this lively discussion. It's been wonderful, and thank you for the audience for sending these good questions. And I think there's still plenty that we didn't cover yet. We will provide some written answers to those after this session, since unfortunately we are running out of time and we need to close this session. Any closing words from the panelists before we end? Short things what you would like to emphasize from today's discussion.
Lauri, you were the first to go.
All right, yeah, and I would say that kind of from my point of view, I think this cooperation between the companies it's crucial. It's crucial for future developments. We can kind of the whole industry can work together, and also this when we see that the future is more kind of a global implementations, more open loop applications, this cooperation between the companies getting more and more crucial. So that's what I would like to see more in the future as well. That let's kind of, if you have questions, if you have some ideas or kind of how crazy it sounds today, hey, please contact us, any of us, and we are always happy to support and work together to find a working solution for that, which kind of at the end drives the applications forward and drives the industry to the next level.
From my side, a different aspect, we are not in a sprint contest. It's really a marathon race. We are building this industry in the long term, and any development in the standard space is always a slow one, takes years to do, but it's always worth it. And specifically to build the scalability, not only in the automotive industry, but beyond, requires advances in the tagging standards, in the identifier standards, data sharing standards, many other either official or unofficial guidelines that industries utilize in order to scale up the adoption of new technologies. So I emphasize we have to keep the eye on the ball also in the long run.
Perhaps from my part, if I had to raise one point not emphasized enough, that would be the quality. Whether it's automotive, that is clearly a quality conscious sector, but for others also, tags really should to provide their value to work for years, since they are manufactured and supplied, and the quality really has to be spot on. Not only that it works when it's manufactured or tested or shipped to customer, but for years forward from that.
Great. Thank you to our panelists. Thank you to our audience. Have a nice evening, have a nice day, and see you at the following events.
Thank you very much.
Thank you.